Okay, let's start the class. Alright, first, what is differentiation? Okay, first, all of you can hear me. Any one of you have difficulty in my voice? Any one of you thinks that my voice is too soft for you? No, right? I hope all of you can listen. Okay. Okay, first, what is the meaning for differentiation? So whenever you see differentiation, first thing come into your mind should be gradient. Alright, because differentiation actually is highly related to gradient. Alright, so first, whenever you see dy dx, you must understand this one actually is called gradient function. Gradient function. Why I said gradient function? Because dy dx actually for you to find a gradient for curve. So for example, if you have a straight line y equals to mx plus c, you can easily find m, because you know m, you just need to take 2 points and then you substitute into the formula like y2 minus y1 over x2 minus x1, then you can get the gradient easily. But then for straight line, the gradient itself is constant. Why do we call constant? Because the gradient will be same no matter at which coordinate, so you will have the same gradient. But then for curve, let's say I have a curve over here. Actually, you will find out that the gradient is keep on changing in every coordinate one. So for example, now I want to find the gradient for this curve. I randomly give the curve an equation. Let's say I give a curve like y equals to, okay, that's very random, y equals to maybe 3x square minus 7x. Alright, so now I have the equation for this curve. Then I want to find the gradient of this curve. So what I will do is, if I want to find gradient, I will do dy dx. Because I know if I differentiate the y, I can actually get the gradient of the curve. Because gradient of the curve is like totally different with the gradient of a straight line. Because gradient of the curve is keep on changing in every coordinates. Alright, so okay, how differentiate happen is something like this. Have a look here. With differentiating is very simple. Do you see the power? Okay, we will move the power in front and then we will minus 1 for the power. So I move the power in front, so you will see I move the 2 here. This is multiple, 3x. Then 2, the power over here will be minus 1. Okay, this is what happens in differentiation. Alright, so for example, if I got minus 7x, if I differentiate 7x, what will happen? 7x means x power 1, right? So I move the 1 in front, I will get the same thing, 7. So 1 minus 1 is x power of 0. So after I differentiate, what I will get? I will get 6x minus 7. Because x power 0, you got 1, isn't it? So you got 6x minus 7, which is the gradient of the curve. So let's say I like simply give you a coordinate over here. Okay, I say this coordinate is, okay, coordinate A. This coordinate, I give a coordinate like 2, 5. Then the question will ask you, what is the gradient at coordinate A? So from here we know 2, 5. The 2 over here is for x, right? The 5 is for y. So for gradient function, the important thing is only the x. You always need to find the x value. So I'm going to substitute the 2 into my dy dx. So I want to find what is my gradient over here. So I will substitute the 2 into here. So my dy dx at a will be 6, 2 minus 7, which is 12 minus 7, I will get 5. That means at a over here, my dy dx actually is 5. So you can find out that the dy dx is keep on changing. Let's say this is coordinate b. B I randomly give you maybe 4, 3. Okay, now if I want to find the gradient at b, so I want to find the gradient of b. So I know that gradient of b actually is my dy dx, but I substitute when x equal to 4. I substitute 4 into my 6x minus 7. So you see 6, 4 minus 7. Then this is 24 minus 7, you got 17. That means my gradient at B is 17, but my gradient at A is actually 5. So this is the meaning of dy dx. So basically dy dx mean gradient for any curve. So the curve can be power of 2, power of 3, power of 5. It can be any curve, but then it means gradient. Means when you see dy dx, please link it to m. It's gradient. It's the same meaning with the m here. But just the dy dx is the m for any curve. Can be quadratic curve, cubic curve, or any exponent curve. Means can be curve in any power. So if you want to find the dy dx, yes, we need to know what is the basic skill about about differentiation, right? So okay, right now I'm going to teach you some basic skill about differentiation. Actually, differentiation is quite simple. Okay, have a look here. Maybe I give you some simple thing over here. Okay, let's say I say y equals to 3x plus 11. Alright, now we want to differentiate this one. Why it will call dy dx? Because we differentiate y toward x. Mean my y and x here is the variable, so we call dy dx. Because sometimes the exam love to give something like this. A equals to pi r square. And then a lot of students, they will make a small mistake. It's like they will write dy dx here because they say differentiate what? So I can write dy dx. Then this is wrong. Because dy dx means whenever you have y toward x, then you write dy dx. But then in these cases, we have to write, we are actually differentiate a toward r, right? So this one we call dA dr. Alright, please remember this one. Not all the time is dy dx. You have to see what is your subject here and what's your variable here. So over this case, I differentiate y toward x. Alright, so you have to understand, if you differentiate 3x, you will straight away get 3. But why? Because this is power 1, right? So just now I say you move the power in front and then your power is minus 1. So now if I move the 1 in front, actually I will got 1 here multiple with 3. And then x will be power 1 minus 1, which is power 0. Plus 11. If you differentiate 11, 11 do not have x at all, you will got 0. So if you differentiate this one, 1 multiple 3, you will got 3. And then x power of 0, you will got 1. So you will got 3. So therefore we come out something like conclusion. So if I got y equals to 7x, so if I differentiate 7x, I straight away get 7. So if I differentiate 7x plus 99, I will still get 7. Because if you differentiate 99, this one do not have x, you will got 0. So please remember this one. Okay, if you differentiate this one, do not have x, you will got 0. Alright, so what happens if you differentiate this one? A equals to like pi r square. So if you differentiate this one, same thing. I will move the 2 in front. So 2 will multiple with pi. Pi is just a number. So here I actually will get 2 pi r. Okay, this is power of 2, right? 2 minus 1 is 1. So this is what happened after I differentiate this one. I will get 2 pi r. Alright, let's see. Okay, we're trying to make the question more difficult a little bit. Alright, let's say I got y equals to 7x power of 3 minus 2x power of 5 plus 3x. Alright, so when I differentiate this one, the faster way I do is, first thing I move the 3 in front and then minus 1, right? So this one later will become 2. So I move the 3 in front. Actually you can straight away like process this one in your brain. Like 3 multiple 7 is very easy, right? So it's 21x square. 3 move in front will be 3 multiple 7 and then x minus 1. So same to this one. You see 5 move in front. I will actually have 5 multiple 2, right? So negative 10 x. The 5 will be minus 1, 4. And And then just now I say if you see 3x, you differentiate, you will straight away get 3. Okay, so far should be okay, right? Because this one is like quite simple. Alright, let me like level up a little bit. Let's say, what is this one? Let's say 7 over x cubed. Okay, what happens if I differentiate this one? So if you want to differentiate this one, you must be very good in indices. Because indices tell us that actually we can change this one to 7x power of negative 3. Isn't it? This one, if I separate them, actually equal to 7 multiple 1 over x cubed. 1 over x cubed is x power of negative 3, right? Okay, if you understand about this one, then you want to differentiate this thing will be very easy. Because same thing like what I said just now, you move the negative 3 in front and then you minus 1. Okay, you see what happened if I move the negative 3 in front. I move the negative 3 in front will be negative 3 multiple with 7x. Negative 3, right, will be minus 1. So what I will have is, I will have negative 21 x power of negative 4. But then in exam, you shouldn't leave it in this. Oh, sorry, this is not y, this is dy dx. My bad. So in exam, you shouldn't leave your answer in integer form. Always change it back to the fraction. So this one will become negative 21 over x power of 4. Alright, so far any one of you do not understand why this one will be x power of negative 3? I believe you will see a raise hand button in your right hand side. On the top of your right hand side. If you have any question, you can raise your hand, or you can straight away type in the chat room over here. Alright, if you have no issue on this, then I'm going to like ask you like trying to do something. Okay, let's see. I randomly give you a question. Y equals to maybe 7 over x cubed minus 2 over x power 5 plus 3 over x. Alright, people trying to differentiate this one, find me the answer. What is dy dx? Okay, try to do this one. I will give you 2 minutes. Should be more than enough to finish this one. Okay, please try to do. Let me know if you have any question or any problem or you cannot understand. Yeah, in order to do well in differentiation, make sure you like understand quite well about the indices lah. Okay, I hope you have some paper and pen or pencil beside you. Yeah, because you can't like just see the question and imagine and you got your answer. So yeah, practice is very important. So yes, if the power is negative, yeah, why? Then I go multiply it, will be negative or positive. Yes, you got back the negative as well. Because like negative multiple positive, of course you will got back the negative. So, alright, so over here, first thing before I start to differentiate, I will always change this one to indices form first. Okay, what do I call indices form is something like this. I will got y equals to 7x power of negative 3 minus 2x power of negative 5 plus 3x power of negative 1. Alright, yeah, I think the Michael Theo got his answer already. Alright, so when I change this one to indices form already, then only I start to differentiate. Okay, you're going to see when I start to differentiate, what will happen is something like this. I'm going to move the negative 3 in front. When I move the negative 3 in front, actually, I will straight away get negative 3 multiple 7, right? So it will be negative 21. And then this one is x power of negative 3 minus 1, negative 4. Alright, so same to this one. Negative 5 multiple negative 2, we got positive 10. This one will be negative 6 because negative 5 minus 1. And same to this one will be minus 3. Because negative 1 multiple 3, you got negative 3. Alright, and then this one is x power of negative 2. Okay, then after you've done this part already, what you need to do is change this one back to the fraction form. So this one will be negative 21 over x power 4 plus 10 over x power 6 minus 3 over x squared. This is the answer. Forget to take the power of negative 1 multiple to 3. Yes, please. Even if it's negative 1, you still need to multiple 3. If not, you got the wrong answer. Okay, so far okay? Okay. If okay, we'll go to a little bit further. So far, anyone cannot understand about what is happening right now? No, right? Okay, then we go to a little bit further. Okay, what happens if you have something like this? 3x plus 7 power of 10, maybe. Alright, this one is a little bit complicated. Okay, so I'm going to teach you the easier way first, and then I'm going to explain how actually the easiest way happens. Alright, so the first thing is I will actually move the 10 in front and then minus 1. Okay, so same like just now. Okay, I will move the 10 in front and then minus 1. This is 9. Alright, so what happened inside the bracket? I will actually copy it according to what I have over here. So it's 10 multiple 3x plus 7 bracket power of 9. And then what will happen next is I have to differentiate inside one more time. You imagine, now you want to differentiate 3x plus 7. So actually, when you differentiate 3x plus 7, you have got 3. Isn't it? You imagine if you got y equals to 3x plus 7, you differentiate this one, dy dx, you have got 3. Isn't it? Yes. Okay, then a lot of students will make a common mistake here. They're trying to multiple 10 inside this bracket, become 30x plus 70 power of 9. This one, you should never do it because they are different power, you cannot multiple in. But then we know this is 10 power of 1, this is 3 power of 1. Both of these is the same power, so I can multiple 10 with 30. 10 with 3, so I got 30. And then this is 3x plus 7 power of 9. Okay. Over here, maybe a lot of students will ask, why actually have to differentiate inside? So I'm going to show you why over here. So first thing over here, let me draw a line. Then I'm going to show over here. First thing, I will let u equals to 3x plus 7. Alright. So I'm going to teach you something like change rule over here. And it's highly related to what we are doing over here. Alright, so in this question, this is u already, right? So I will got y equals to u power of 10. So if I differentiate this one, is differentiate y toward u, right? So here I should write dy du. Alright, this is simple. We move the power in front minus 1, right? So it will be 10u power of 9. Alright, and then here I have to differentiate the u. Why I need to differentiate u, I'm going to explain when I explain the change rule. Alright, so u is what? 3x plus 7. So if I differentiate u towards x, here we'll call du dx. Because I differentiate u towards x over here. So I will got 3. Okay, right now here, if you want to get dy dx, which is what we want, we have to learn something called change rule. I will draw a line here, draw a line here, and then I do multiple here. So here I will write dy, here I will write dx. And then here I will write something they have in common, which is du. Do you find out actually they have du in common? Du and du. Alright, this is something very important. They actually call this one as change rule. Okay, how change rule happen is something like this. You imagine This is du over du, right? Imagine if you can cancel du over du. Okay, because they are the same thing, right? You just have simplified them. So you still get back your dy dx, right? Yes, this is how the dy dx happen. Alright, okay, so you're going to have a look here. I got dy du. What's my dy du? It's tan u power of 9. Multiple, my du dx will be 3. So multiple 3. So over here, my dy dx will be 30 u power of 9. So what's in my u over here? Will be 30. My u will be 3x plus 7 power of 9. So you can find out that actually this one and this one, they are totally the same thing, isn't it? Yes. That's why I always teach students about this method, because for me, I think it's very easy. You just move the 10 in front and then minus 1. Whatever you have here, you just copy. And then after that, you differentiate inside one more time, you put at the back, and then you multiple this number. Right? If you just like cannot understand this method, you love to use the chain rule method, yeah, you can do that as well. But it will spend you more time in doing this, because this is one of the past year question also. The question actually like give you the u and then they ask you to solve it. Alright, so far so good. I hope you can understand. If you cannot understand, please raise hand. Yes, I see someone raise hand over here. Alright, for Mingyuan, what is your problem? Let me see. Got bracket, only do like this. Depend your bracket. If you got the bracket, this bracket power is bigger than 2, mean you hardly expand this one, then yes, you have to do like this. For example, like this one, 3x plus 7. You got the bracket as well, but it's bracket 2. This one actually not necessary you need to do this one. You want to do this one, can also, or you can straight away expand this one. What? Y equals to 9x squared plus 42x plus 49. I expand already, then only I do dy dx. Then what I will have is, I will actually get 18x plus 42, isn't it? Alright, so I'm trying to use this method, see whether I can get the same answer or not. Oh, sorry. Let me erase this one nicely. Alright, let's see. This one is what I got, right? 18x plus 42. Okay, right. Let's say right now, I use the method over here. See whether I get the same answer or not. 3x plus 7 power of 2. So first thing is, I say when you differentiate, you move the 2 in front. So you got 3x plus 7. Alright, this is 2. 2 minus 1 power 1. And then you differentiate inside one more time, you got 3. 3 multiple 2 is 6. This is 3x plus 7. Then 6 actually you can multiple in, right? So you got 18x plus 42. See, actually both also give you the same answer. Alright, so yes, I hope I answer your question. So whenever you got something like bracket and power is like very big, or sometimes it's very small, you also need to do this way. So if you understand this one, I'm going to show you about the bracket which is very small. Okay, I'm going to erase this one. What happened to this one? Okay, let's say let's say I got y equals to 3x squared plus 7 power of 1 over 2. But sometimes exam won't like so nice give you 1 over 2. Exam will give you something like this. Square root 3x squared plus 7. And then they ask you to like find the dy dx for this one. So first thing come into your mind is, you must understand square root mean power 1 over 2. If the question give you cube root, means what? If the question give you cube root, this one means the whole thing power of 1 over 3. Please understand about this one. Alright? Because this is so important. And then if you not understand about this one, please go ahead to revise the indices. Alright? So, let's say, exam already like straight away give me about this one. Okay. Then now I want to differentiate this one. Okay, you see what will happen. This is like power 0.5, right? So, what will happen is the same. When I differentiate it, I will move my power in front, and then I will minus 1 for this one. So you can see, if I move my power in front, it's 1 over 2. And then this one I just copy. And then 1 over 2 minus 1, what you got? You got negative 1 over 2. Alright, after you've done this part, please do not forget differentiate inside. So you need to differentiate inside. What you will have is, imagine you differentiate 3x squared plus 7, you will got 6x. This is power 1, this is power 1, right? So you can multiple. Never multiple 1 over 2 into this bracket become 3 over 2 x squared plus 7 over 2. This is so wrong, okay? This one you can multiple with 6x, you got 3x. So, this is power negative, right? Whenever power negative means 1 over the whole thing. So, I will get 3x squared plus 7. Power 1 over 2 means square root. This is my answer. Alright, so far okay? Got no problem, right? Or do not understand what is happening right now at all. Alright, so let's try to do something. The answer only left it like that. Yes. Normally, if you ask about dydx, you can leave your answer like this. Of course, in the exam, he'll ask you to find a gradient. Then if he give you when x equals to 1, then you're going to substitute x equals to 1 into the whole equation. Then you solve it, then you will got in decimal maybe. Okay, so please take a piece of paper and trying to do this. Maybe I give you 7 minus 4x squared power half. Alright, trying to differentiate this one. I give you one minute to try to differentiate this one. Make sure you understand what is happening right now. Very simple. Move the power in front, minus 1, and then differentiate inside one more time, and then solve it. Try to do it right now. Okay, I see that actually Mingyuan got the answer already. But I'm not sure it's correct or not. I'm going to check it later. Alright. Okay, so it's very simple. Okay, have a look here. So first thing is, I'm going to move the 1 over 2 in front. And then here I will just copy whatever I have. And then 1 over 2 I will minus 1. So I got negative 1 over 2. Alright, then I'm going to differentiate inside one more time. Which is, this one will give me negative x. Isn't it? So, this one I can multiple with this one. I will got negative 4x. Alright, then what I will have is over, because this is power negative, right? Means over 7 minus 4x squared, square root the whole thing. Yes, this is the final answer. Yes, for Liang, you forget about your x, because it's not negative 4, it's negative 4x. Because this one, you differentiate inside this one, will actually give you negative x, right? Yes, so please be careful when you do something like this. Okay, I hope you all have some basic understanding about this one. Of course, about the product rule and quotient rule, I think have not enough time to like finish today. So we're going to go through some past year question. Yeah, I hope some past year question actually can help you understand better. Okay, can all of you have a look at this one? Okay, congratulations for Aliang. Yeah. Alright, so have a look at this one. Just now what I say is, I say the dy dx mean gradient, right? Mean gradient function. mean m. Okay, I always love to use m to represent gradient because everyone know y equals mx plus c. Alright, so something you should learn in the Form 4 quadratic, if you got a curve, on the maximum here, we know the gradient will equals to 0. Okay, whatever, your gradient will equal to 0 in whatever condition like this. You will got maximum, it will equal to 0. You will got minimum, it will equal to 0. This is the first condition. Second condition, sometimes they say stationary point. Stationary point. Then the gradient is equal to 0. Third condition, sometimes they say turning point. Okay, all this condition is gradient will equal to 0 means dy dx will equal to 0. You must understand this one very, very good. Means whenever the curve go until the maximum, whenever they want to turn, over here this line, over here this line, the gradient actually will equal to 0. So whenever the question say maximum point, minimum point, stationary point, turning point, first thing come into your mind is the gradient is equal to 0. Alright, of course if the question asks you to find the coordinate, you know you can use the completing the square to do that. But then that one is not for this chapter. So first thing is, I want you to understand maximum and minimum, the gradient is equal to 0. Alright, should be okay, right? Not too bad. So I'm going to erase this one. Okay, have a look on this question. This question, he give you something like this. Okay, a lot of students might think this question need to use product rule. But whenever you can expand it easily, please do not use product rule because it just wastes your time. Unless you like very good in product rule, then you can straight away do. So in this question, first he asks you to find the values of y, find the values of x when y is maximum. A lot of students might think how to find because the question doesn't ask me to find gradient. So I have no idea do I need to dy dx or not. So but you see the words maximum. Maximum and minimum in MX, you only like few chapter you will see maximum and minimum. One of the chapter is like quadratic function, which is ask you to find the maximum point or minimum point. But then in differentiation, you can do that easily. So I'm going to expand this one. Y equals to 15 multiple 6 will give you 90, right? So 90x minus 15x squared. Alright, I know whenever the maximum means dy dx equals to 0. Alright, so first thing here, I will do dy dx. Alright, so what I will do over here is I differentiate this one first. This one will give you 90 minus 30x, right? Easy, 90x you got 90. The 15x squared, 2 move in front, minus 1. Alright, then dy dx will equal to 0, right? Because it's maximum. So 90 minus 30x equals to 0. So basically 30x will equals to 90. You got x will equals to 3. So find the values of x when y is maximum. So now I got my value of x easily. 2 mark. Alright, then he asks you to find the maximum values of y. So you're going to find the maximum value of y by substitute the x into the y here. So I got y equals to 90, x is 3, right? Minus 15, 3 square. So this is quite simple, which is 270 minus 9 multiple 15. What you got 9 multiple 15? 9 multiple 45, 135. So your y, okay, your y is slightly big. I hope my calculation got no mistake. 135. This is B. This is just a 3-mark question. It's not really hard. But then if you couldn't get the hints, yeah, it might take you some time to do that. Of course, I believe you actually can get the answer by using the completing the square method. You got the same answer, but I'm not going to cover that one in this video. I mean in this virtual classroom. Alright. So far okay? So whenever you see maximum or minimum, means you understand the curve turn until the maximum or minimum over here, the gradient will equal to 0. Alright. So far okay? If okay, we're going to go to see the next question. Alright. Okay, this one have to use product rule. Okay, then later Okay, let me just like erase this one, and I erase everything, and then I put in another, upload another question. Let's see, just wait for a while. Q3, 4. Let's see whether this question is same with this question or not. Alright, have a look this one. Alright, this is one of the famous question also. So in function, whenever you got fx, we never write dx something like this. So whenever we differentiate function one time, we write one dot for it. This one means differentiate one time. If I differentiate again, I will write two dot for it. This means differentiate two times. Please do not confuse this one with this one. This is -1. This one is inverse function. Alright, this is one dot. This one is something like complement in set. Alright, so this one means differentiate one time. Two dot means differentiate two times. Alright, you got it? So you see g two dot mean actually you're going to differentiate gx two times. Alright, I hope you understand about this one. So have a look this one. So first thing, before I start to differentiate, whenever I see 1 over, I always will change this one to the indices form. Alright, so my gx, if I change to indices form, it actually equals to 2x minus 4 power of -2. Alright, because if you not understand this one, it's hard to help you. Imagine just like 1 over a square. This one is called a power of -2, isn't it? Indices. Then I start to differentiate first time. I put a 1 dot for it. Alright, so you can see I move my -2 in front, and then this is 2x minus 4. -2 minus 1, -3. I differentiate inside one more time, I will got 2. This is power 1, this is power 1, I can multiple. This one become -4. Whole thing got power negative, right? So I can write over 2x minus 4 power of 3. Or actually you can leave in this form because you're going to differentiate one more time again. So yeah, you don't need to write in fraction form so fast. You just differentiate one more time again. So this is -4, 2x minus 4 power of -3. Alright, then I'm going to differentiate second time. Same thing, I move the power in front, become -3 multiple -4, which is positive 12. This is 2x minus 4 minus 3, right? So become -4. And then differentiate inside, I got a 2. So 2 going to multiple 24. So this one will be 2x minus 4 power of -4. Then I write in the fraction form will be 24 over what? Over 2x minus 4 power of 4. This is the answer, 3 mark in SPM. Alright, so far okay? I hope you're okay. So please do not confuse yourself. So whenever you see 1 dot, mean differentiate one time. 2 dot mean differentiate two times. And not necessarily is G. They can be in G, in F, or in H, 2 dot or 3 dot. Alright, you have to know this thing means actually differentiate 3 times. It's not like impossible to understand, right? Yes. Then I'm going to like upload another question. Yes. If like cannot understand, please let me know. Okay, wait for a while. I'm going to upload another question. Okay. Where is the other question? Just wait for a while. Okay, let's see this one. Okay, I hope you can see the question. Alright, okay, this is something related to paper 2. So, need to substitute 1 into x, right? What do you mean by substitute 1 into x? Okay, for Aliang, I'm going to like reply you later. We have a look on this question first. Because this question is quite important because it's highly related to paper 2. because you see the word something like normal. Alright, so over here I'm going to explain what is the meaning for normal. Alright, if I have a curve like this, okay, I'm going to draw a line for, okay, have a look here. I'm going to call this line as tangent line. Okay, whenever I call tangent line means what? This straight line actually touch the curve at one point. And then at this point, the curve and the straight line will have the same gradient. So important to understand that both of them have the same gradient. So I repeat one more time. Let's say I give you an A. In the point A, the straight line and the curve will have the same gradient. Only at point A. Alright, not point B, point C. At point A. So for example, this tangent line, I give it an equation. Y equals to 3x plus 5. So this is the equation for straight line, right? So from here we can straight away know the m is 3. Means what? This is a tangent line. So at A, I know my gradient of curve at A is equal to 3. This information is very, very, very important. So that means at A, my dy dx will equal to 3 because of this equation give me. I know y equals to mx plus c. So my dy dx is 3 at A. Alright, this one called gradient of tangent. So you see something like this, gradient of tangent means the gradient of tangent line. Mean also the gradient actually touch one point over here, means yeah, same gradient. Normally I understand the tangent like same gradient. Alright, so far okay? Okay, if okay, then I'm going to explain what is the meaning for normal. Okay, same thing over here. If I have a tangent line over here, normal means actually it will form 90 degrees to the tangent line. We call it normal. So this is the tangent line, correct or not? This is a tangent line. So if the tangent line and this line is 90 degrees, we call this line at normal line. Alright, for just now, we call this equation y equals to 3x plus 5, right? So we know the gradient for this line is 3. Then we want to find the gradient for this line. Let's say I call this line AB. I want to find the gradient of AB. Because of 90 degree, in geometric coordinate chapter, we learn about perpendicular. When they are 90 degree, we have some formula called m1 multiple m2 will equals to -1. Alright, this formula is for perpendicular. Whenever got 90 degree, we use this formula. So I can get the gradient of normal easily by gradient of AB multiple gradient of tangent, which is 3, equals to -1. So gradient of AB will equals to -1 over 3. Then I can easily get this gradient is, the gradient for this one will be -1 over 3. This one called gradient of normal. Alright, got some idea about what is normal? Normal means it is perpendicular to tangent. Normal means it is perpendicular to tangent. Please remember this one. If not, you cannot solve paper 2. Because paper 2, you always see tangent and normal. Tangent means they have same gradient. Okay, you can understand it this way. Normal means actually it will be 90 degrees to tangent. Alright, I hope you understand. Alright, so we're going to have a look on this question. I'm going to erase everything. Oops. Oh my god. Okay. I'm going to erase everything here. Okay. I want to erase this one. Erase this one. Erase this one. Let me erase. Alright. Have a look on this question. He said the point R lies on this curve. Alright. It's given that gradient of normal at R is -1 over 6. Find the coordinates of R. So over here, if you cannot imagine, I'm going to roughly draw out this thing for you. Alright. And then I randomly call some place as R. which is I will have some tangent which is touch one point. Okay, let's say I call this one at R. This is point R. And this equation is given, right? Y equals to x minus 3 square. Alright, over here he never give you the gradient of tangent, but then he give you the gradient of normal. Normal means what? Normal means you will have another line which is perpendicular to R. Wait, I'm going to move this line. Okay, which is perpendicular, which is 90 degree over here. And then he give you this gradient. This is the meaning gradient of normal. Okay, so gradient of normal over here will be negative 1 over 6. This is the gradient. Huh? Alright, so gradient of normal will never have the same gradient with this curve. Because we can only get the same gradient by getting the gradient of tangent, which is this line. So I want to find the gradient of this one. So I'm going to use negative 1 over 6 multiple m2 equals to negative 1. So my m2 obviously is 6. So I know this gradient of tangent is 6. 6 is the gradient of tangent. Okay, gradient of tangent at R, that means I know at R over here, the curve and the straight line will have the same gradient. So I know that dy dx is 6 over here. Because they have the same gradient, then I can get the coordinate R easily if you get this idea. So what I will do is, I got y equals to, I can expand this one, easily x squared minus 6x plus 9. Then I differentiate this one, dy dx will give me 2x minus 6. Alright, so over here, my dy dx equal to 6, right? So 6 will equals to 2x minus 6. So 2x will equals to 12, x will equals to 6. Alright, then I want to find the coordinate. Coordinate means I need to have x and y. So I need to find my y also. So I'm going to substitute my x back to my y. So y will equals to 6 squared minus 6 plus 9, which is y equals to 9. Then I can get my coordinate r easily, which is 6 and 9. Done. So far, is it very hard for you to understand? Because this part, a lot of students were very confused about normal and tangent. So far, can you understand or not? No, yes, yes, no. Yeah. So, a lot of students will ask me the question like this. If I do not know how to sketch the graph, how do I solve the question like this? Okay. I'm going to show you how can you solve if you do not... Oops. Wait. Okay, let me erase everything. So this time I'm going to like redo this one very fast, without really sketch out the graph. So first thing is, when I do this one question, first thing is, I write out the equation first. When I see gradient in whatever equation have power more than 1, so I will link to my mind, I know this is dy dx already. So first over here is, he give me gradient of normal, then I know I cannot use this gradient. So what I will do is, I will straight away substitute this one to find the gradient of tangent. Okay, I call it gradient t, stand for gradient of tangent, equals to negative 1. Then I straight away get my gradient of tangent equals to 6, because I moved the negative 1 over 6 to the other side. Alright, then I know I can use this one to find my answer. Because gradient of tangent at R will be same with the curve. Alright. Alright, so I know I want to get I will know I want to get the gradient, I need to differentiate. So yeah, I can differentiate this one very fast, dy dx. If I do not want to expand, yeah, I can straight away do like this. And then this is power 1. Differentiate inside one more time, I got 1. So basically it's 2x minus 6. Alright, so here I will write dy dx equals to 6 at R. This is what I will answer in exam. So what's my dy dx? So 2x minus 6 will equals to 6. So x will equals to 12 divided by 2, 6. Alright, so then I substitute x equals to 6 into y into y equals to, write the whole thing lah. So y will equals to 6 minus 3 square, which is 3 square. Y equals to 9. Alright, so therefore coordinate r will equals to 6 and 9. Yes, you can do like this if you really can understand about this thing. So if let's say the question changed a little bit already, the question straight away give me the gradient of tangent, then I will skip this step. I straight away use dy dx equals to negative 1 over 6 to straight away do this one, because I know gradient of tangent means at that point the curve and straight line have the same gradient. Okay, so far okay? Yes, so in exam, yes, this is how you're going to solve this kind of question. Yes, if you can understand this one, it will be very helpful for you in paper 2. Because paper 2 somehow you can be like 6 mark question for this one. Okay? Yes, what is the time now? Yes. Let's see like 1 or 2 more questions. So I'm going to erase everything over here. Okay, let me like just upload another question. Okay. Alright, just wait for a while while uploading this question. Alright, this is a question I mentioned just now. And actually quite a lot of students come to my Facebook to ask me about this question. Yes, they ask me how to find dy dx if the question gives you like this. This one is what I say just now. You have to use change rule. Still remember the change rule I mentioned just now? If you want to find dy dx, in this case you see the u in common, right? So you draw a line, you draw multiple. Here you write dy, here you write dx. And then here you have to write something in common. Because I see u, so I know here is du over du. So you're going to use this you're going to use this one so-called change rule to solve this question. Alright, so how are we going to use a chain rule? Okay, so first thing is, yes, I got 4 over 5 u power of 3, right? I differentiate this one, called dy du. Please do not write dy dx, right? Okay, so you differentiate, I say power move in front minus 1, right? So 3 multiple 4 over 5, we got 12 over 5. Minus 1, you left 2. Now I got dy du. See, I got dy du already. Now here, give me u equal to this one, right? So I'm going to substitute in. No, I'm going to write it down. First, I don't substitute in first. So, obviously, if I differentiate this one, I can get my du dx. This is u, this is not y. This is u. Alright, so I differentiate u toward x. So I call du dx equals to 5. Alright, so if du dx equals to 5, okay, now I got everything already. I'm going to substitute in. So my dy dx actually will equals to my dy du equal to this one, 12 over 5 u square. Multiple, this is 5. Do you see that? Then I multiple 5. I know 5 and 5 I can simplify. I got 12 u power of 2. But because dy dx, we know we cannot leave our answer in u, because must be x over here. So I'm going to substitute what's in my u. My u will be 5x minus 2 square. This is my answer for 3 mark. Alright, so far you can understand, because this one is, I don't know, maybe it's one of the famous question. And a lot of students, when they see the question like this, they will like panic, because first thing student will feel panic because over here they didn't see x, and over here they didn't see y, so they cannot link. How can they actually get dy dx from this kind of equation? So this is how we do. So please remember this one change rule, because it's going to be very important in next part of differentiation. Means later actually you will learn about the rate of change. You're going to use chain rule a lot over there. I think someone is Michael Teo, you got any problem? Need to open the bracket? Don't need. You can leave your answer in this pattern. But I think if you open the bracket, you multiple it in, the question, the examiner will still give you correct. So don't need to be so worried about that lah. Alright, I think yes. Any more question before we end the class today? Yeah, really appreciate your participate. Any more question? Yes, please go and take some past year question or anything, trying to do as many questions as possible and trying to find out any question you cannot do. Just now question. Yeah, for Aliang, what's your question? Your just now question, you mean this question? Or the question about the tangent and normal thing? Yes. Oh, is it just now they asked me to... Okay, sorry, I didn't see the just now question carefully. If you say G2.1, right? So what you need to do over here is, you have to substitute 1 at the end. So after you differentiate 2 times already, you substitute 1 into the x. Yes. Yes for Aliang, yes. At the end, because just now, at the end I only do 2 dot for x, right? So if you see the question 2 dot for 1 over here, so that means at the end, you got your equation. Remember to substitute 1 into all the x. Okay? Yes. So if okay, I think, yeah, that's all for today class. And this Sunday actually I will have another class for differentiation, but that class actually I will teach in Mandarin. Yeah, if you are free, please join it. If you are not free, it's okay. It's on 8 p.m. Yes. Just now that question, if without giving the normal, how to do? Not so understand. Okay, for the question just now, the question will either give you the gradient of tangent or the gradient of normal. Normally the question will give you a gradient if the question want you to find coordinate. But not necessarily it will ask you to find coordinate all the times, because sometimes actually the question will ask you to find the equation of tangent or equation of normal. Yes, I hope I actually can schedule another class next week to explain further about this one. Yes, because in today's class I just trying to cover things in paper 1, and I'm not sure why the paper 1 you will see the tangent and normal thing also. But yeah, somehow that makes a little bit, yes. No problem. Yes, if he give tangent 1, then skip the... Yes, if the question give you the gradient of tangent, you no need to do m1 multiple m2 equal to -1, because that formula is you want to find the gradient of tangent or normal, then only you use that. So if the question straight away give you the tangent one, you can straight away use dy dx equal to that gradient. Okay, can you understand, Mingyuan? Yes, then yeah. So far, I think that's all. Yeah, no problem. I just hope you can understand. But please go and do some practice, because you're going to forget whatever I teach right now very soon. Yes, like you never touch it like 1 week, you're going to forget how to do the differentiation. Yes, if I will announce the time very soon, like maybe these few days. Yes. Yeah, actually Sunday I teaching same thing about the differentiation also, but then I just use the Chinese to teach, because some students, I'm not sure, maybe they can't understand my English very well, so I'm going to teach in Chinese. And then yeah, if you understand this one very well, you don't need to join about the Sunday classes, because it's the same thing but just in Chinese. But you can try to do some exercise. If you got some question, you can ask me in the Sunday class as well if you want. Yeah, sure. All of you are welcome to join. Alright, so I'm going to like off very soon. So if no problem, I'm going to see you very soon. Bye bye. See you soon, people. Okay, bye bye.